Hi, my name is Vicky Chang, and today I'm going to talk about predictive human performance modeling made easy. The paper I will talk about today is called Predictive Human Performance Modeling Made Easy, and it's by John et al. It's from the proceedings of the SIG-Chi Conference on Human Factors in Computing Systems, April 2004. And we know that predictive modeling is useful for many different applications. I've put down several examples. The first example is, of course, to point out inefficiencies and maximize profits. And as shown in this paper by Swart, which uses predictive modeling in context of restaurant operations to optimize operations and productivity. It is used for user attitudes and decision making, such as this paper by Perugini, which uses explicit and implicit attitudes to predict decision making, and varied aspects of usability, such as hardware, such as this paper by Cockburn. That examines performance with constrained input interfaces such as switches, and even subtle topics such as quality of experience for internet video that leads to or would allow for greater revenues in ad sales. So you can see that predictive modeling is used in a variety of different HCI applications. So there are several issues, however, with predictive modeling. And first of all, every system, every predictive modeling system must be validated and should be validated in real-world situations. Second, it can be hard to implement for many UX practitioners since the models are based in complex math equations, and in several instances, you may need to know specialized programming languages or special programs to run these models. And likewise, it can be difficult to customize or change once a model has been done. So it's not very flexible. So the authors of this paper had a very clear goal: to make accurate predictive modeling tools easy for the UI, UX designer or engineer to implement. They came up with 3 rules that must be kept in mind as they were designing the modeling program. First, they wanted to exploit tools already in widespread use by the UI, design, and cognitive modeling communities. They wanted to connect interface mockups to cognitive models, so changes in the mockups are automatically reflected in the model's predictions. And third, they wanted to avoid the need for learning new programming languages. So the program design they came up with, keeping these 3 important factors in mind, is that they decided to build in predictive modeling tools into Dreamweaver, which utilizes an existing program widely used by UX practitioners. It needs no special or additional training or extra programming knowledge. And in Dreamweaver, it's easy to add customized tools. The predictive models, the predictive cognitive models, are based on these models, existing models, ACT-R and ACT-Simple. ACT-Simple is related to a very widespread, widely used model called the KLM, or keystroke level model. ACT-R simulates human behavior and performance and allows models to interact with external environments such as pressing buttons or typing keys or pull-down menus. And ACT-Simple is the compiler for ACT-R, which communicates with the mockup interface, allowing for the user's actions to be recorded and compiled. And both ACT-R and ACT-Simple are widely used and validated models. The authors added a behavior recorder capability to Dreamweaver, which generates the ActR code automatically. And the behavior recorder capability in Dreamweaver contains many options such as text fields, buttons, checkboxes, links, pull-down menus, so the designer can customize their mockup. You can input text to simulate audio inputs as well as outputs. And existing web pages can be modified in Dreamweaver using this behavior recorder function without the need to rebuild the page from scratch. So here are some screenshots of Dreamweaver with the rapid modeling capability. The mockup is created in Dreamweaver with the modeling capability, and you can see the menu here with the recording tab. It has a customized tool palette of instrumented widgets. So the mockup is created in Dreamweaver and with the modeling capability, and then the mockup is demonstrated, shown here in Netscape. And when the mockup is demonstrated, the task is exported from the behavior recorder into ActSimple, which translates the actions into ActR and automatically generates time predictions. So with every model, you need to validate. So for the paper, their experimental validation is identical to that of several past papers on predictive modeling. And they do this to allow for head-to-head comparison with data from past model systems, past validated model systems. The experiment is simple. It's 2 tasks and interfaces to validate. The tasks are to look up 1 or 2 telephone numbers from a database, and the interface is either a dialog box or a pop-up menu. So these mockups were made, and 2 people were asked to create models based on each interface and task, one who is an expert and another person who is a novice. So here are the results. Here are the comparisons of user data to predict the predictive models of execution time. And in this chart, you can see 4 different modeling platforms, 3 past modeling platforms, and then the one from this paper. So in blue is the actual user data, and in yellow are the predictions from each respective model. And as you can see, the numbers are extremely close between the actual user data and the numbers from this paper. And another note is that the other 3 modeling systems were not automated, and even so, they're compared to this paper's automated system. So the results show that the platform described in this paper had the least amount of error and the highest accuracy compared to user data than past model systems, even those that were calculated by hand. Expert and novice users had almost the same task times because the numbers are generated by the program itself and not affected by the experience level of the user. And the time it took to model was significantly different between the expert and the novice. The expert took only 3 minutes versus the novice's 25 minutes. But either time wasn't terribly long or excessive. So in conclusion, if validated predictive modeling systems were more easy to use and more customizable, it could be an important tool for those working in the field of HCI. And the authors have successfully created and validated an easily accessible and customizable predictive modeling tool for use by UX practitioners. It can be used with existing software, integrated into mock-ups of interfaces, and easily customized and changed according to need. It automatically generates accurate predictions, not dependent on experience level of the user. And it is validated and actually more accurate than other published predictive models. Future directions. Predictive modeling could be applied to more real-world situations and help find areas of inefficiencies and error more quickly. So in the future, it would be nice to test this predictive model system on more users instead of just one novice and one expert. And it would be nice to see just how customizable and easy it is to use across a variety of tasks, not just the 2 tasks and 2 interfaces that were used for the validation. The authors asked very interesting questions about using predictive modeling more commonly where it hasn't been used before in application development. And those questions are, when should predictive modeling be employed in the development of an application or a product? And how will these predictions inform design? And so those are 2 questions as predictive modeling is used more and more, those questions can be answered and might have many different answers. And so far, many companies offer predictive modeling services, but I haven't found many that offer programs that work with existing software that the user can tailor to their specific needs on a small scale. Thank you very much for your time, and I hope you have a very nice weekend, and thanks for listening. Bye.